Energy, around us, an untapped resource. Our planet is awash with energy. The sun bathes us in light and warmth. The wind whips around us full of kinetic energy. Even the ground beneath our feet holds geothermal heat. For too long we have relied on finite and polluting sources like fossil fuels. But what if we could tap into the energy that surrounds us every day? This is the promise of energy harvesting. Imagine a world where our cities power themselves. Imagine buildings that generate electricity from sunlight and vibrations. Imagine roads that capture energy from passing cars. This is not science fiction. Energy harvesting technologies are already being developed and deployed around the world. One of the most exciting areas of energy harvesting is in transportation. Our cars, trucks and buses are constantly in motion, generating vast amounts of kinetic energy. This energy is typically lost as heat and noise, but what if we could capture it and put it to good use? The potential benefits of energy harvesting are enormous. By tapping into these untapped resources, we can reduce our reliance on fossil fuels. We can create a cleaner, more sustainable future for generations to come. The journey towards a greener planet begins with harnessing the energy that surrounds us. Every object in motion possesses kinetic energy. The faster an object moves and the heavier it is, the more kinetic energy it has. Think of a large truck rumbling down the highway. It carries immense kinetic energy due to its weight and speed. Traditionally, this energy is lost during braking. When the brakes are applied, the kinetic energy of the vehicle is converted into heat, which dissipates into the environment. This process is not only inefficient, but also contributes to wear and tear on the braking system. However, innovative technologies now allow us to capture this kinetic energy instead of letting it go to waste. This process, known as regenerative braking, is already used in some electric and hybrid vehicles. By capturing the kinetic energy during braking, we can convert it back into electrical energy and store it in the vehicle's battery. This extends the vehicle's range, reducing the need for frequent recharging or refueling. While kinetic energy recovery from braking offers a significant opportunity, moving vehicles possess other untapped energy sources as well. These sources, often overlooked, hold the potential to further enhance energy harvesting in transportation. One such source is waste heat. Internal combustion engines found in most conventional vehicles generate a significant amount of heat during operation. This heat, often released into the atmosphere, represents wasted energy. Thermoelectric generators, capable of converting heat differences into electricity, can be strategically placed within the vehicle's exhaust system. By capturing and converting this waste heat, we can supplement the vehicle's electrical system, improving fuel efficiency. Furthermore, solar panels integrated into the vehicle's body, particularly the roof and hood, can harness solar energy to power auxiliary systems like lights, air conditioning, and entertainment systems. This reduces the load on the engine, further enhancing overall efficiency. By exploring and utilizing these additional energy sources, we can maximize energy harvesting from vehicles, paving the way for a future of cleaner and more sustainable transportation. Imagine driving on a road that generates electricity as you pass. This is the vision behind road energy harvesting, an emerging field with the potential to revolutionize transportation infrastructure. Instead of focusing solely on the vehicle, road energy harvesting systems are embedded within the road surface itself. These systems capture energy from passing vehicles and convert it into usable electricity. This innovative approach offers several advantages. Firstly, it allows for energy harvesting from all types of vehicles, regardless of their engine type or energy efficiency. Secondly, it provides a continuous source of energy as long as there is traffic on the road. Several promising technologies are being developed for road energy harvesting. These include piezoelectric systems, which generate electricity from pressure, electromagnetic induction systems that utilize magnetic fields, and thermoelectric generators that capture heat from the road surface. Each technology has its own advantages and challenges. However, they all share the potential to transform our roads from passive infrastructure into active energy generators, contributing to a greener and more sustainable transportation network. Imagine vehicles driving over tiles that capture energy. As vehicles drive over these tiles, their weight exerts pressure on the crystals, generating small amounts of electricity. While the amount of electricity generated by a single tile may seem insignificant, the cumulative effect of thousands of tiles on a busy highway can be substantial. This energy can then be used to power streetlights, traffic signals, or even fed back into the electricity grid. Several pilot projects around the world are already testing the feasibility of piezoelectric roads. In Israel, a company has installed a stretch of piezoelectric road that generates electricity from passing vehicles. While piezoelectric roads show promise, there are still challenges to overcome. The durability of the piezoelectric materials in harsh weather conditions and the cost-effectiveness of large-scale deployment are areas of ongoing research and development. Energy in motion. This principle states that a changing magnetic field can induce an electric current in a nearby conductor. In the context of road energy harvesting, coils of wire are embedded in the road surface. As a vehicle passes over these coils, its motion relative to the magnetic field induces an electric current in the wires. This technology offers several advantages. Firstly, it is less sensitive to weather conditions compared to piezoelectric systems. Secondly, it can generate more energy per passing vehicle, making it potentially more efficient. However, electromagnetic induction systems also face challenges. The need for strong magnets and the potential for interference with other electronic devices are areas that require careful consideration. Despite these challenges, electromagnetic induction holds significant promise for road energy harvesting. Research and development efforts are ongoing to optimize the design and efficiency of these systems. Thermoelectric generators work based on the Seebeck effect, which states that a temperature difference between two dissimilar conductors can generate an electric voltage. By embedding thermoelectric generators in the road surface, we can capture the heat generated by passing vehicles and convert it into electricity. This technology is particularly effective in warm climates where the temperature difference between the road surface and the ambient air is significant. While thermoelectric generators offer a promising solution for harvesting waste heat from roads, their efficiency is currently limited by the availability of high-performance thermoelectric materials. Research efforts are focused on developing new materials with improved thermoelectric properties, which could significantly enhance the efficiency and viability of this technology for road energy harvesting. The concept of solar roadways is appealing due to its potential to generate clean and renewable energy on a large scale. However, there are significant challenges associated with this technology. Environmental analyst. One major challenge is the durability of the solar panels. Road surfaces are subjected to heavy loads, impacts, and harsh weather conditions, which can damage the delicate solar cells. Another challenge is the cost. Solar roadways are significantly more expensive to install compared to conventional asphalt or concrete roads. Despite these challenges, solar roadways represent a bold vision for a future where our transportation infrastructure not only facilitates transportation, but also generates clean energy. To maximize energy harvesting potential, researchers are exploring hybrid systems that combine multiple technologies. For example, a hybrid system could incorporate piezoelectric materials for capturing energy from braking, electromagnetic induction coils for harvesting energy from constant speed traffic, and solar panels for generating electricity from sunlight. By combining the strengths of different technologies, hybrid systems offer the potential for increased energy harvesting efficiency and reliability. These systems could play a crucial role in creating a sustainable transportation infrastructure that reduces our reliance on fossil fuels. Large-scale batteries, similar to those used in electric vehicles, can be installed alongside roads to store the harvested energy. This stored energy can then be used to power streetlights, traffic signals, and even nearby homes and businesses during peak demand periods. Smart grid technologies, which enable two-way communication between energy producers and consumers, can optimize the distribution and utilization of harvested energy. For example, If there is a surplus of solar energy being generated by solar roadways during the day, it can be directed to nearby buildings or even used to charge electric vehicles. By integrating road energy harvesting systems with advanced energy storage and smart grid technologies, we can create a more resilient, efficient and sustainable energy infrastructure for our cities and towns. This integrated approach will be crucial in transitioning towards a future powered by clean and renewable energy sources.